Hey guys, what is up? Quackware here. This is basically going to be a small kind of mini series where I'm going to cover, in general, just a variety of topics revolving around big data and Amazon EMR, which stands for Elastic MapReduce. And in Amazon EMR, we are going to be using Hadoop and HBase, basically to take a large data set, which could be anything, but in this case, it's going to be public New York City taxi data for 2013. Things like length of trip, fare, um, the different medallions that the taxis have, which is a very large amount of data. And we're basically going to take this data, import it into Amazon EMR, into Hadoop and HBase, and then we are going to run various MapReduce scripts on it and try and find, some interesting or useful information out of it. And this will both be a learning experience for me, and hopefully you guys will learn something out of this as well. Basically, if you ever come across a large data set and your existing tools aren't really enough, hopefully you'll be able to learn how to handle this large amount of data. And even though this doesn't really cover the scale that Hadoop and HBase is meant for in terms of terabytes of data, it's still like a really good learning experience that if you ever need to scale up to that amount, you can have this experience already. So that's pretty much a general overview. Here's some of the topics that we'll be talking about in the introduction, which is this video, and the next video will be setting up Amazon EMR, basically provisioning our server, talking about the various configuration, SSHing into it. Then we'll be taking a look at our data set, kind of looking at the different fields that we have, try and think of some sort of HBase schema that we can create that'll make sense in terms of querying data from. Because we want to be able to, in the end, we want to be able to query and run MapReduce basically as quickly as possible. If we ever want to transfer this data to a system like Spark, where we can have real-time aggregated queries, we want to be able to structure our data so that that is possible. And then the next tutorial will basically be configuring our server, doing things like installing the necessary packages, making sure that our data is in the right place, that kind of stuff. And then the bulk will be writing our bulk upload MapReduce query, where we will be loading the large gigabytes of data into Hadoop HDFS. And from HDFS, we will be importing it into HBase. And then the final one, before we kind of go into basically tutorials that people want to hear about, we'll be writing the MapReduce script that will be taking this data from HBase, analyzing it, and generating useful statistics out of it. Some things I have in mind at the beginning are things like finding, what the best time to drive a cab is in terms of income earned, finding fun things like who drove the longest in a year or who made the most money, stuff like that. So just kind of like interesting statistics. Okay, so to talk more specifically about Hadoop, here is the main Hadoop page. And Hadoop is basically, it's composed of several different parts, and it is based on the white paper for Google Bigtable. So this is basically the open source version of Bigtable. And the different parts, as you can see here, are Hadoop Common, which I guess is just kind of like general purpose things that other Hadoop modules use. There is the Hadoop Distributed File System, also called HDFS, and this is basically a multi-cluster distributed file system that allows you to store large amounts of data. So if you can imagine the amount of data that Google has, they use a system very similar to HDFS to store that amount of data. There is Hadoop Yarn, which is basically job scheduling and resource management. And then there is Hadoop MapReduce, which are simple, Java or in some cases, other programming languages, jobs that you can run against these large data sets that are stored in HDFS. So you can think of HDFS just as a normal file system and MapReduce just as scripts that you can run against them. And as you can see, these are the various technologies that kind of run on top of or in sync with Hadoop. HBase is one which we will be using in this tutorials. There's also some very good ones like Cassandra and Spark, which we might visit later. Spark specifically because it basically is MapReduce 2.0 or an improved version of MapReduce. And we may talk a little bit about Zookeeper, which is basically, it tells, you know, Hadoop and HBase, it's used as kind of the coordination between the various clusters that we have. Since we'll be composing a multi-server cluster, they need to talk to each other, so we'll be using Zookeeper for that. But it's pretty much in the background. We don't really have to touch it very much. Okay, and HBase is basically a NoSQL, you know, random access database built on top of HDFS. So you can imagine HDFS as, you know, the file system, and HBase is basically a way to query large amounts of files that are stored on HDFS in a random, like, and simple way. So you can think of it as just, you know, a database built on top of files, and it's able to utilize this, you know, very like good distributed nature of HDFS to store huge amounts of data. We're talking about terabytes. So it's a lot simpler in terms of you can write queries that, you know, select a value based off of a column name or a column value or a row key or things like that, rather than Hadoop by itself doesn't really have that property, since you can only run MapReduce queries and get those results back, or get the actual files that are stored in HDFS. So it's just going to be very useful for what we're trying to do. And again, this is overkill. This is designed for terabytes and terabytes of data, but I think it's like a great learning experience, and it can teach us a lot. Alright, so that's it for the introduction. The next video, which you should probably watch right away, is going to be about setting up Amazon EMR. Thanks for watching. Quackware signing out.